Alright, so this is going to be part 1 of 2, going over the study guide for this test, quest, quiz, whatever we're calling it, on Thursday and Friday of this week, okay? So what we're going to do is we're just going to go through a few of these problems and make sure that we're good with it all. We also are going to have the online live review sessions during our classes, so questions can be asked then. Alright, so let's start with question number 3. So the instructions say to simplify. Okay. So I am being told to divide these two fractions. All right. So remember, when you divide by a fraction, that's just leave, change, flip. That's multiplying by the reciprocal. So what we're going to do is, first of all, factor these things. So this is 3 goes into both 30 and 21. Yep. Okay. 3r squared times, okay, that's going to be 7r minus 10 over. Okay, so first of all, what can we do here? We can factor out how much? 2. So that's 7r squared plus 4r minus 20. Okay. And now we're going to do times, because we have to flip that second one. Okay, I can factor out a 2 to start on top here. And now on bottom, nothing happens. Alright, so what we've done so far is we've started our factoring. Now these are a little bit more complex, so there's going to be a little more factoring to do. But we've started our factoring, and we've multiplied by the reciprocal. Okay. Now, I can already see there's a 3r squared here and a 3r squared here. So I'm going to go ahead and forget about those. Not have to write those every time. Okay, so we have 7r minus 10 over 2 times... Oh, there's also 2's up there, aren't there? Cool. By 2, by 2. Okay. So let's erase this. Okay, so now factoring this on bottom. Ooh, that's not going to be very fun, but we can do it. So there's going to be a 7r. There's going to be an r. Okay, so factors of negative 20, and I'm going to have to maybe do some trial and error here. Okay, so let's see. Factors of negative 20 are what? Negative 4 and 5. Okay, and I've got to make a 4 in the middle. So let's say I do negative 4 here, plus 5 here. That's going to give me 35 minus 4. That's not going to work. Okay. So let's try something else. So it looks like 4 and 5 are not going to work. So maybe 2 and 10. So if I put plus 2 minus 10, that's going to give me negative 20, so that's good. But then it's going to give me negative 70 plus 2r. Don't think so. Let's try to flip them. Which would make a lot of sense because there's already a 7r minus 10 on top. So maybe that's going to go better. So if I do this, then that's going to be 14r minus 10r, which does give me that 4r. All right, cool. So then times... That's going to factor into what? R plus 2r minus 2. All over 1. Okay, so we've got 7r minus 10 and 7r minus 10 that cancel. We've got r plus 2 and r plus 2 that cancel. Oh, wow. This ends up just being r minus 2. Cool. All right, so what we did was we factored everything out, and we leave, change, flipped. We multiplied by the reciprocal to get our new expression. All right, so there's that. That's going to be the same for 1 through 4. Okay, so the next simplifying ones have to do with adding and subtracting. So remember, when we add and subtract, we're going to have to get common denominators. Okay, so let's look at number 8. Okay, so on number 8, our common denominator is going to be x minus 5 times x plus 3. Hopefully that's pretty obvious. If you notice, I made these a little bit easier than the ones that we've done previously. Okay, we're going over the highlights for this test thing, not the hard stuff necessarily. Okay, so this left side is going to need an x plus 3. Okay, and this right side is going to need an x minus 5. Oops. Okay. All right, so now let's combine these things. So we're going to distribute, okay? Remember, that's really a plus a negative 3x there. So we got to remember to distribute the negative 3x. Okay. So this is 5x plus 15 minus 3x squared plus 15x all over x minus 5 times x plus 3. Okay. So we have negative 3x squared plus 20x plus 15 all over x minus 5 and x plus 3. All right, so now we've got to see if negative 3x squared plus 20x plus 15 factors. I'm going to guess that's a big fat no, but let's see. So, so if I do like 3 times 5 and 1 times 3, that's not going to get me there. Yeah, that's not going to factor. So there's our answer. Okay, so common denominators, and you got to fix everything. And then you've got to just simplify it all and get your final answer. All right. Complex fractions. So 9 through 11. Okay. This is where you're going to have to get common denominators on top, common denominators on bottom, and then simplify it all down. So let's look at number 10. Okay. All right. So on top, it looks like my common denominator is going to be x squared. So I'm going to need a 9x. Ooh, no, I am not, am I? That one's already fixed. So 9 over x squared plus, all right, this one needs an x. So x times x plus 4 all over. Whoa. All over. All right, on bottom, it looks like it's going to be x times x plus 4 as our common denominator. So the left one needs an x. Minus, all right, the right one needs an x plus 4. All right, cool. So we've got our common denominators. So now we get to simplify it all into single fractions and leave change flip. So let's see, I've got 9 plus, that's x squared plus 4x over x squared times x times x plus 4 over 3x minus, let's see, that's going to FOIL into x squared plus 9x plus 20. Okay. So this is x squared plus 4x plus 9 over x squared times x plus 4 over negative x squared minus 6x, right? Yep. Plus minus 20. Okay. So let's see. Looks like nothing here factors, but there is an x on top and bottom. So that's going to make one of those go away. But it looks like that's about all we can do. So our final answer, as crappy as it is x squared plus 4x plus 9 times x plus 4 all over x times negative x squared minus 6x minus 20. And like I said, while that is crappy, that's an answer. That's completely valid. Okay? Alright, so complex fractions. Get your common denominator on top, get your common denominator on bottom. They do not have to be the same. Okay? And then you've got to leave, change, flip, and call it good. Alright, moving on. Let's look at the graphs. So I would like to do number 13. Okay, I'd like to do number 13. So remember, the very first thing that we always do with these is completely factor and cancel. Okay, so we've got come on and work with me. Whatever. All right. X plus 4, x minus 3 on top. Okay, on bottom we can first factor out a negative 4. Okay, so we've got x plus 4 times x minus 3 over negative 4 times x minus 2 times x plus 1. Okay. So it looks like nothing cancels out, which means there are no holes. Okay? Remember, if something cancels, that's when there's a hole. Okay? All right. So now let's move on to writing all our information down. So let's start with vertical asymptotes. Okay, so on bottom, we've got to see what makes the bottom 0 after we cancel everything out. And that's x equals 2 and x equals negative 1. Okay. Horizontal asymptote. All right, that's where we have to look at those rules. Okay, so if we look, it looks like the degree on top and bottom are the same. They're both x squared. So we need to take the ratio of their leading coefficients. So that is negative 1/4. Whoa, that's bad. Let's try that again. Okay. All right, now let's find some x-intercepts. So we're going to set the top and bottom equal to 0. So on top, we're just going to set the top equal to 0. So that's negative 4, 0, and that's 3, 0. Okay. Y-intercept, we got to plug in 0. So if you do that, you're going to end up getting negative 12/8, which is negative, what? Negative 3/2. Okay? All right, so there's all of our important information right now. So our asymptotes, -1 and 2 and -1/4. Okay. So we've got x-intercepts at -4, at +3, and a y-intercept at -3/2. All right. Well, if you look at this, we have something in all 3 of our sections that are separated by vertical asymptotes. So this means we are not going to need any extra points at all, which is really nice. Okay. So we just know it looks like this here. It's a parabola in the middle. And like this on the outside. Okay? Cool. So remember, if we did not get something like that, we would have had to do extra points and go in and plug in something that was in the X range that we didn't have. Okay? All right. We're almost done with this one. Yeah. Okay. So rational equations. So let's do one of the difficult ones. Let's do number 19. Okay? So rational equations. Remember, the goal here is to get common denominators throughout the entire problem. Okay? So looking at this first one, if we factor that denominator, we're going to get k minus 4, k minus 2. Okay. So it looks like the left two are the same already, which is kind of nice, but the right one needs a k minus 2. So we've got k minus 5 over k minus 4 times k minus 2. We've got 1 over k minus 4 times k minus 2. And over here, we're going to need the k minus 2. All right. So once you have common denominators throughout the entire problem, you get to cancel out those denominators. Okay. So if we forget about them, we get k minus 5 plus 1 equals 4k minus 8. All right, so we get that, let's see, add the 8 over, so that's 4 equals 3k. So then k is equal to 4/3. All right, so you get common denominators through everything, and then you forget about the denominator, and you solve it like a normal problem. All right, that's